Hi friends, we welcome you all to the video series of 8051 microcontroller. In the previous two videos, we have gone through definition of microcontroller, difference between microcontroller and microprocessor, and the block diagram explanation. Today, we are going to learn the pin description of 8051 microcontroller. This video series is presented by RLC. Without wasting our time, let's start the topic. First, we'll see how to read the pin numbers. When we are going to read the pin number of any IC, we need to hold this notch to the top. That means this notch should come to the top. Vertically, we need to hold it in such a way that the notch will come to the top, or else we can see there's a dot. This dot should be in the left top corner. Whenever we are going to read the pin numbers, we should keep this notch to the top and this dot to the left top. Then reading the pin number we should start, this left top will be represented by 1 and it goes down. We can see over here the left top represents 1 and it increases as it goes down. That is 1, 2, 3, 4. We can see here it ends with 20 because 8051 microcontroller is a 40 pin microcontroller. Now 21, where to start the 21? Now we got from 1 to 20. 21 has to be started. That 21 has to be started from the lower right bottom. That is, it increases from lower right bottom to the top. Increases from lower right bottom to the top. In the right top corner, we'll have the final pin. We'll have the final pin. So 8051 is a 40 pin microcontroller. So we can see the left top will be the pin number 1, then the left bottom will be the pin number 20, then right bottom will be the pin number 21, then right top will be the pin number 40. Okay. This is how we are going to read the pin numbers in the 8051 microcontroller. Now we'll see with the supply pins. That is, whichever IC we are going to take, okay, those ICs require supply for its proper working. Same as it is, our 8051 requires a DC supply, a constant DC voltage supply. Where we are going to connect, that we are going to observe. We can see over here in the pin number 40, I have changed this to red color, and the pin number 20, it has been changed to black. Pin 40 and pin 20. So we can easily say that the pin 40 is the plus VCC. We can say this is the plus VCC, and pin number 20 is the ground pin. Pin number 20 is the ground pin. 8051 microcontroller works with a voltage of plus 5 volts. 8051 microcontroller works with an voltage of plus 5 volts with reference to ground. This is with respect to the supply pins. So plus VCC is with the pin number 40 and ground is with the pin number 20. Next, whenever we are going to work with any IC like microcontroller or microprocessor, those requires the clock pulses for its operation. That is, whenever we are going to work with microcontroller or microprocessor, it requires clock pulse for its operation. 8051 has its partial oscillator circuit inside. For providing the external clock pulse, we have this pin number 18 and pin number 19. We have the pin number 18 and pin number 19, which we call it as XTAL2 and XTAL1. Okay, for the XTAL2 and XTAL1, we are going to pass the clock pulse. We can pass it in two ways. One is by connecting the crystal oscillator and one is by connecting external frequency. First, we'll see with how to connect with crystal oscillator. Crystal oscillator is connected across XTAL1 and XTAL2. That means we are going to have an crystal oscillator. This crystal oscillator is connected to XTAL1 pin and XTAL2 pin along with a capacitor which are grounded. with the capacitor which are grounded. Okay, this crystal oscillator can be with the frequency from 10 megahertz to 30 to 40 megahertz depending upon 8051 family. Okay, we can connect from 10 megahertz to 30 to 40 megahertz depending upon the 8051 family. Usually normal purpose we'll be connecting 11.0592 megahertz crystal oscillator for 8051 microcontroller. We'll be connecting 11.0592 megahertz crystal oscillator for 8051 microcontroller. This is by connecting quartz crystal oscillator. We can also pass the clock frequency directly through signal generator or something else to one pin that we'll see in the next. Now, by external frequency, how we can connect it? For the external frequency, we are going to leave any one pin, like we are going to leave this XTAL1 2 pin blank. This is with no connection. Then for the XTAL1 pin, we are going to pass the clock pulses. For the XTAL1 pin, we are going to pass the clock pulses. This is how external frequency can be provided to the 8051 microcontroller for the as a clock pulse. Now, reset signal. Reset signal, it is like, say, when we are working with a program, like a program is being executed, if there is any error or if we are going to stuck at one point, if we are not getting the proper output due to some reasons in the wrong code or anything else, we need to reset. Or if we want to start from the beginning, okay, we will be resetting the things. To reset, 8051 has a pin at number 9, which is an reset pin. At pin number 9, which is an reset pin. This reset pin is an input pin. This reset pin is an input pin. This pin, if we are going to apply a positive pulse, if we are going to apply a positive 5 volts pulse, then microcontroller will stop its all operations and it resets the value of SFR to its original position. And main thing is like the program counter register value will be 0000H. That means whenever a high pulse is being given to the reset pin, microcontroller terminates all its operations and it resets the values of SFR and all the registers. At the same time, the program counter, okay, register will be set to 0000H. That means the program is going to start from beginning. The program is going to start from beginning. That is the reset signal pin. One more main thing we need to keep in mind is like this width of the pulse. It should be minimum 2 machine cycle. Width of the pulse should be minimum 2 machine cycle. Then only a proper reset signal will be applied to the 8051 microcontroller. What is this machine cycle and all, we'll go through that next. Okay, remember that the pulse width of the reset signal should be minimum of 2 machine cycle for the proper reset operation. Next, we'll see with how to identify the IO ports. How to identify with the IO ports. Until now we have gone with this VCC 40 pin, ground 20, XTL 218, XTL 119, then the reset pin 9. Okay. This IO ports are going to take most of the pins in the 8051. We can see we have studied in the block diagram. We have 4 ports, each ports with 8 pins. So we have 32 pins out of 40 pins. Okay, 32 pins are for IO ports. 32 pins are for IO ports. In that, the first port, that is P0, starts from pin number 39 to pin number 32. It starts from pin number 39 to pin number 32. Then the port 1 starts from pin number 1 to pin number 8. That is from pin number 1 to pin number 8. Then next, the port 2 starts from pin number 21 to pin number 28. It starts from pin number 21 to pin number 28. Then port 3, it is from pin number 10 to pin number 17. If you want to remember the sequence of this port, you can remember it like the reverse Z. That is, first we have the port 0 here. We start from here. Then it goes to port 1, that is left side. Okay. Then we'll get to port 2 like this. Then port 3 like this. So to remember which all the places the ports are being placed, you can remember like the reverse Z fashion. The right top is port 0, the left top is port 1, then the right bottom is port 2, then the left bottom is port 3. Now we'll go with each and every port separately. We are going with port 0 first. This port 0 is having 8 pins, which we can represent as P0. That is, port 0 can be represented as P0. For each and every pin, we should give the naming, because port 0 is going to have 8 pins. So for each and every pin, we are going to give the naming, which is of P0.0, P0.1, 2, 3 until 7. That means from 0 to 7. Always we need to remember, okay, the port numbers or the bit numbers in microcontroller start from 0. It always starts from 0. Okay. Now P0.0 to P0.7. There are 8 pins. There are 8 pins. And this pin number starts from top to bottom. That means 0 to 7. It increases from top to bottom. And in the block diagram we have studied like this P0 is also an pin which can be used for the data and it can be used for the address. That is, lower order address pins is also present in the port 0 and the data pins are also present in the port 0, which we represent as AD0 to AD7. That is, P0.0 represents AD0, same as it is P0.7 represents AD7 as it is. So port 0 starts from pin number 39 and ends with pin number 32. That is 39 with P0.0 and 32 with P0.7. That is with port 0. Next, if we go with port 1, port 1 pin starts from pin number 1 and it ends with pin number 8. It starts with pin number 1 and it ends with pin number 8. Same as port 1 can be represented as P1. Then each pin in that can be represented as P1.0 until P1.7, which makes 8 pins. So if we check it over here, P1.0 is the pin number 1 and P1.7 is the pin number 8. And as it increases, here also we can see the pin number increases as we move from top to bottom. As we move from top to bottom in port 1. In port 1. Next, we'll see with the port 2. In port 2, the main difference is like in port 0 and in port 1, we have seen the pin number increases when we move from top to bottom. Pin number increases when we move from top to bottom. That means Px.0 and it increases to Px.7. like this. But in port 2, it is different. It moves from bottom to top. It moves from bottom to top only in port 2. So you should remember while writing, okay, port 0 and port 1, the pin number increases from top to bottom, whereas in port 2, the pin number increases from bottom to top. So we can see P2.0 is pin number 21 and P2.7 is pin number 28. As we have seen in the block diagram explanation, P2 is also a multi-functionality pin where higher order address pins are present in port 2. Higher order address pins are present in port 2, which we represent from A8 to A15. A8 to A15, that is P2.0 represents the pin number A8, then P2.7 represents A15. This is with port 2. Now we'll move on with the port 3 pins. Port 3 pin start from pin number 10 and ends at pin number 70. Same as port 0, port 1, port 3 pin also increases from top to bottom. That is port 3.0 is pin number 10, port 3.7 is pin number 17. Only in port 2. Okay, remember while writing in exam or somewhere else, only in port 2 the pin number increases from bottom to top, but port 0, port 1 and port 3 it will be from top to bottom. This port 3 is also a multifunctionality pin where this port 3.0 and port 3.1 uses for serial communication. It is used for serial communication. This port 3.0 is an RxD pin, which means it is going to receive the data. It receives the data, and TXD pin is the one which transmits the data. Transmit the data. That means for the serial communication, P3.0 and P3.1 pins are being used. Next, if we move with the P3.2 and P3.3, it is an interrupt 0 and interrupt 1 pin. These two pins are external interrupts. These two pins are external interrupt pin. Same as reset, like we have seen with the reset. Okay, we have a reset pin. When we press the reset pin, microcontroller is going to stop all its operations or terminates all its operations and resets all the values to 0, and program counter will be set to 000 location. Same as it is, if we want to interrupt something, if we want to say that like whatever been executed, it should be stopped and we should move to particular function or particular operation, means we can use this int 0 and int 1. We'll see with how to configure all those things, okay, in the future videos. We'll remember now P3.2 is an interrupt 0 pin and P3.3 is an interrupt 1 pin. These two are external interrupt pins. Then 8051 is having two timers. 8051 is having two timers. These two timers are represented as T0 and T1. Timer means which counts the clock pulse which has been in the 8051, that is internal clock pulse. Timer which counts internal clock pulse. Say if I want to measure the external clock pulse, if I want to measure an external clock pulse, then I can make use of the same timers T0 and T1, okay. By passing the clock pulses to P3.4, I can make T0 as counter. I can make T0 as counter by passing pulses to P3.4 pin. Then same, I can make T1 as counter 1, T1 as counter 1 by passing frequency to P3.5 and configuring the timer to be set as counter by using tmod register. We'll see in the future, like tmod register, tcon register, all those things we'll see in the next one. This is with T0 and T1 pin, which is with P3.4 and P3.5. Next, we have still two more pins left, that is P3.6 and P3.7, which is used for external memory access. Like whenever we want to read or write the data from the RAM, external RAM, from external RAM, this WR pin helps in writing the data, then RD pin helps to read the data from that external RAM. WR pin helps to write the data to the external RAM and RD bar pin helps to read the data from the external RAM. These are all the special functions available in port 3, which we have gone through. Next, we are remaining only with 3 more pins. We'll go with those pins. What is its speciality? All those things. Now, first we'll move on with the pin number 31. Okay, this pin number 31 is an EA bar / VPP pin. That is, EA means external access. EA means external access. Okay, if this EA bar pin is equal to 0, which means 8051 will be connected to 8051 will be using external ROM. Will be using external ROM. If that EA bar pin is equal to 1, then it will be using internal ROM. Then it will be using internal ROM. Then we have one more function of this pin, that is VPP. This VPP pin receives positive 12 volts when it is in flash programming mode. When it is in flash programming mode, this EA/VPP pin receives positive 12 volts. That is with EA bar and VPP pin, which is of pin number 31. Next, we'll go on with the pin number 30. Okay, this pin number 30 is an ALE/program bar pin. That is, ALE means address latch enable. Address latch enable. We know that the pin number from pin number 39 to 32, as we have seen now, it is of port 0. It is of port 0. This port 0 pin is having both address and data. It is having both address and data. To distinguish between whether this pin is carrying address or this pin is carrying data, this ALE pin is being used. This ALE pin is being used. If the ALE is equal to 0, if this ALE pin is equal to 0, it indicates port 0 is carrying data. If the same ALE pin is equal to 1, it indicates port 0 pins carrying address. Port 0 pin is carrying address. And this pin is also having another functionality, extra functionality, that is, whenever we press the reset pin, that is, whenever we apply positive +5 volts for reset pin, it terminates all the functionality and it starts from the beginning. Before starting from the beginning of the code, it checks with this pin. It checks with this pin. If this pin is been with 0, that is, if this pin is connected to 0, okay, it enters to flash programming mode. It enters to flash programming mode. That is the reason we could have been seen whenever we go for programming the 8051 microcontroller, first we'll press the reset button. When we press the reset button, it terminates all the functions and it resets all the values in the SFR and the registers to 0. That is to the default value, not 0, to the default values. Then before executing the code, it checks with this pin. that is the pin number 30. If this pin number 30 is connected to 0, microcontroller enters to the flash programming mode. Microcontroller enters to the flash programming mode. Next, we'll see on with one more pin, which is of PSEN, We call this pin as program store enable. Program store enable. This is an active low control signal pin. This pin is an active low control signal pin. It is used to activate external ROM. It is used to activate external ROM. One more main thing is like this pin, okay, will be activated only when we are going to use MOVC instruction. MOVC instruction, that is there are two instructions, that is one is MOVC A comma at A plus DPTR and one is MOVC A comma at A plus PC. It is a program store enable pin. It is an active low control signal used to activate external ROM. It is used to activate external ROM. Hi friends, this concludes the explanation of 8051 pin diagram. In the next upcoming video, we'll see with the RAM structure. If you have enjoyed the learning, click the like button and share with your friends and well-wishers. Connect with us in our social media platform for more updates. We are updating the theory content of this in the website. You can check the link in the description. Thanks for watching. We'll continue our journey of learning in the next video.